Okay, so last Monday, okay, I've introduced to you on what is hypothesis testing. Okay, so I just want to sum up because I'm sure uh, many of you still do not understand the concept of what is hypothesis testing, what is null hypothesis, what is alternate hypothesis. So I will just briefly explain in the next 2 or 3 minutes again. Okay. So whenever you want to do hypothesis testing, you need to develop two statements. One is the null or the HO, and the other one is H1 or the alternate hypothesis. So what is the difference between the two? So basically, whenever you want to perform a hypothesis testing, okay, you collect a sample information from a sample, and that sample is supposed to prove the statement of H1. If you recall, the burden of proof is on the H1. So for example, if someone tells you, I mean, let's say from past information, okay, using the same example, okay, we claim, I mean, let's say from past information that we know that the monthly expenditure of UUM student is RM 500 a month. Okay, student UUM spend around 500 ringgit per month on food. Okay, but if you feel that the value now has increased, okay, because of the pricing, the price of goods and services has gone up, and okay, so if you feel that the value actually is not 500 but actually is more than 500, so you want to prove that the statement, so whatever that you want to prove, okay, so that will be on the H1, okay, on H1. So that's why whenever you perform hypothesis testing, okay, as I mentioned before, start by constructing your H1 first. What do you want to test? If you want to test that, if you feel that it's not 500 ringgit, okay, but you feel that it is more than 500. So if you feel that it is more than 500, so H1 will be H1, the mean should be more than 500 ringgit. So if that is what you want to prove, okay, remember the burden of proof from the sample is supposed to support H1. Okay, because if you feel that H1, the mean actually is not 500 but more than 500, so you are going to use the more sign for H1. So therefore the notation or the symbol for H0 will be less or equal to 500. Okay, so the same goes with any other things that you want to, any other statement that you want to prove. If you feel that the value is less than 500, let's say from past information, someone mentioned in a report or a study that UM students spend 500 ringgit, but now actually you feel that no, it's less than 500, not supposed to be 500. So if you feel that it is less than 500, then this is what H1 you want to test. Okay? The burden of the sample is to support H1, whereby you feel that the mean is less than 500. So once you know what is your H1, then your H0 will be mean greater or more than 500. So this is what the idea of H1 and H0. Okay, and then of course you will need to go through the 5 steps procedure, constructing your H1 and your H0, and then determine the significance level. The common one is 1% and also 5%. So this will be given to you from the question. Okay. Number 3, determine what test you want to use, whether you are going to use Z or T test. So again, from the information provided, you will determine whether you are going to use Z or T. Z is when the sigma is given from the population. T is when the sigma is given from the sample. In most cases, you are going to use T test. Okay, in the real world also, we are going to use t-test, not the z-test, because it's very difficult to get sigma from the population. But from the book itself, you will see the chapter is divided into 2, okay, using z and also using t. And then once you will have determined what test you want to do, okay, and also you determine what we call as the critical value. Okay, critical value means the dividing point. So how do you get this critical value? Is based on the test that you want to use. If you're going to use Z, okay, then you're going to refer to the Z table. If you're going to use the T test, refer to the T table to determine what is the critical value. Okay, so once you determine the critical value, you can draw your area under the curve, okay, whether it's one tail or two tail test. Okay, one tail is when your notation is either less or more than. Okay, more than means that the area will be on the right side of the test. Less than means that the area under the curve will be pointing to the left side of the distribution. But if it is a two-tail test, means that the sign of H1 takes not equal to, then you are going to perform a two-tail test. Okay, so and then construct your decision rule. Okay, when are you going to reject H0? Okay, remember, whenever you start the statement of reject, your decision rule will always refer to H0, whether you reject or do not reject H0. Okay, nothing, you're not going to write reject or do not reject H1. Okay, the decision is always about H0. Okay, if you're going to support H1, means you are going to reject H0. If you cannot support H1, means that you cannot reject H0. So for the decision rule, okay, today we're going to discuss this further in detail, because if you look at this, I'm sure you will not be able to understand how. But basically, if you are going to use two tail, then you're going to test on both sides, whether negative or positive value. So that's why what you see here, the notation is modulus, meaning that you do it can be negative or positive. Okay, but if you test on the left side, H1 is less than, then it will be on the left tail. The value of the calculated Z or T will be less than the critical value. Okay, if you're doing one tail test on the right, you are going to reject H0 if the calculated Z or the calculated T is more than the critical value. How do you get the calculated T or Z? Using the same formula as what you saw in the confidence interval before, okay, or in the sampling distribution, X minus mu divided by standard error. Okay, so simple formula to determine what is the calculated T. Okay, so today we are going to look at the first part of the hypothesis testing, whereby testing when sigma is known, meaning the sigma is taken from the population. So by now you should know already, just like in your confidence interval topic. So this item, this statement is going to refer to, meaning you are going to refer to the Z distribution. Whenever sigma is known, use the Z distribution and also the Z table to determine what is the value that you are looking for. Okay, so which statement that refers to sigma is known from this information given to you? Okay, so if you look at this, when you read, okay, first glance, okay, first get what are the information that you need to extract. Okay, so first, what will be your H1? Okay, what will be your H0? Okay, as I mentioned, the burden of proof, the sample information that you from the sample information that you extract from this statement is supposed to help you to construct H1, because whatever that you want to test is supposed to support H1. So see what is your H1, and then you can know construct what is your H0. So here you can see that the weekly production plan of this company, okay, follows a normal distribution with a mean of 200 and sigma of 16. Okay, so the first statement actually refers to the general information, meaning this is referring to the population value. Okay, not from the sample. From the sample, it will mention, okay, a sample from last year, okay, yielded a mean of 203. Okay, so first, when you look at this statement here, so you have two information. One is the sample mean, which is the X bar, and this one, okay, so what is this mean for? If this is X bar, then this automatically will be the population mean, mu. Okay, because the value of 16 comes together with in the same statement of the population mean. So indirectly, sigma 16 is also referring to the population sigma. Okay, meaning we use the notation population sigma, not the S. So S is referring to sample standard deviation. Okay, so this information in this sentence here refers to general information from the population. Okay, so this is what they know. The company claimed that the mean is 200. Okay, they can produce 200 desks. okay, with the standard deviation of 16. Okay, but when they introduce new method, maybe they hire new staff, okay, increase the number of workers, they bought new machines or whatsoever, okay. So they believe that the mean actually has changed. So the keyword here, which is italic, the word change, okay, if you recall from our last Monday lecture, okay, what are the keywords that you normally use to detect whether you're going to use more than, less than, or not equal to sign for H1? Okay, one of the common keywords whenever you want to refer to has changed or any difference. Okay, so is there any difference? Okay, is there any changes? Okay, so this word refers to when H1 follows the not equal to sign. Okay, so in this statement here, okay, so the keyword that points to your H1 is the company wants to know if there is any changes or any change or any difference. Okay, because from the past information, they know that 200 mean, the mean is 200. Okay, and the population sigma is 16. Okay, but after they employ new workers and change the production method, they believe that now the mean is no longer 200, but it's different than 200. So here and then they take a sample, whereby from the sample they get the number of the mean to be 203. Okay, but in this slide here, something is missing. Okay, because they don't. You need to have actually what is the number of the sample size. Okay, so yeah, the sample size is 15. Okay, so if you look at here, so in your slide, you might want to add this information in the slide. Okay, a sample of, okay, 50. Okay, it's supposed to be here, but I'm not sure why they maybe, okay, some typo error or so you need to add in your slide, okay, a sample of 50 equipments or something lah. Okay, so they take a sample of 50 equipments, okay, from 1 week, okay, and they find that from this 50, the mean is 203.5. Test using 0.01, or in other words, this is 1%. Okay, it can be mentioned as the value in terms of perpuluhan, decimal, or you can also look at in terms of percentage. 0.01 means 1% significance level. Okay, so if you look at this statement here, so first you need to extract the relevant information. First, what is the population mean? Okay, and then what is the sample mean? Okay, and then what is the sigma? What is the standard deviation? And whether this sigma, is it sample standard deviation or population standard deviation? If the sigma is from population, you are going to use the Z. Of course, this topic already mentioned that sigma is known, meaning that if you look at this statement, okay, the idea why sigma is population, because when they mention the word 200, the mean of 200, it comes together with the sigma of 16. So it belongs to the same sentence. If this information is not given here, okay, then that sigma will be introduced or will be mentioned somewhere here in the statement of the sample. Okay, a sample of 50 yielded a mean of 203.5 and standard deviation of 16, for example. If that is the case, then sigma is unknown, meaning you are going to use T. So that's how you detect. Actually, it's quite simple. Once you follow or once you do several questions on this, then you get the idea why this is Z, why this is T. So if I were to remove this sentence from this part, okay, I remove the standard deviation 16, but I put the value 16 here, which belong to this sentence. Okay, because from that 50, we know that the mean is 203 and the sigma is 16. So that clearly shows that that sigma is calculated from the sample. So, but that is not the case in this slide, because here we want to introduce using Z distribution first. Okay, of course, as I mentioned, in the real world, whenever you do research, it's very unlikely that you will know what is the sigma of the population. So most likely you are going to use the T distribution. So most of the questions that you see in the book, or maybe even in your assignments later on, okay, will be based on the T distribution. Okay, but you need to know both, of course, lah. Okay, because that is part of the syllabus. So Once you know what are the information that you want to extract, what is the mu, what is the sample mean, and then what is your sigma, whether your sigma is from the sample or population, because that will determine whether you are going to use Z or T distribution. In our case here, we are going to use Z because the sigma is taken from the population. And then the most important question is, and then also what is your level of significance? 1%. Okay, so this will be provided as well. Okay, so you need actually just this information. What is your population mean? What is your sigma? Sorry, what is the sample mean, X bar? What is the standard deviation? Whether it's Z, whether it's sample or population. Okay, and then what is the level of significance? Okay, 1%. Okay, so after you have extracted this information, then you need to know what is your H1 and what is your H0. The most important part is constructing your H1 first. Okay, so what is your H1? Okay, H1 dot dot. Okay, so H1 will always start with mean, whether the mean is more than, okay, whether it is less than, or whether it is not equal to. Okay, remember, because H1 can only take this form, whether more than, less than, or not equal to. So in this case, it's clearly stated that you want to see whether there is a change. So, so H1 will be, okay, of course, this is shown in the next slide, okay, but I just want to, okay, make sure that you understand how to construct H1 from the statement that you get what you want to prove. Okay, again, the burden of proof, whatever information that you extract from the sample is supposed to support H1. So the company believe that the mean has changed. So it will be mu not equal to. Okay. So the change meaning or any difference, it will be mean not equal to. The question is, what is the number that you want to put here? Okay. Because when you write mu, mu means population mean. So just now I mentioned when you extract the information, which one is the X bar, which one is the mu. So that will help you actually to write your H1 properly or correctly. So mu will be not equal to 200, okay? Because this is what the population mean says, not 203.5, because 203.5 is your X bar. So if you put mu not equal to 203.5, it is completely wrong, because your H1 is supposed to represent the value of your population mean. Okay, so population mean is given to you as 200. So once you have correctly constructed your H1, then you can write on top of your H1 what is your H0, which is just the opposite of your H1. If H1 takes the sign of not equal to, then the opposite of not equal to will be equal to 200. Okay, so once you have correctly formed your H1 and also followed by your H0, okay, and then you have extracted all the information, what is the X bar, what is the sigma, what is the mean, population mean, and also what is the level of significance, 1%. Okay, from here also, if you look at the steps just now, okay, the 5 steps procedure, okay, so you should know already what is the, okay, so number 1 is clear. Okay, you already constructed your H1 and your H0. Level of significance is given to you as 1%, 0.01. Determine the test statistics. What test are you going to use? Because sigma is given from the population, you are going to use Z test statistics. Just mention the test statistics will be Z test. Okay, because sigma is given. Okay, and then step 4, formulate decision rule. Okay, so from here, you must go back to step number 1 as well. How do you construct your H1? H1 is not equal to, means that not equals to will be 2 till test. Okay, I mentioned just now, if your sign will be not equal to in your H1, then you are going to construct a 2 till test. Okay, so 2 till test, your decision rule will be something like this. Okay, so now let's go back to this example here. Okay, so H1 not equal to 200. Okay, and then H0 mean will be equal to 200. Okay, so the keyword here has changed or any difference. Okay, so there are, if you look at the question from the past years or in your textbook, okay, it can be, is there any changes? Is there any differences? Okay, is there any changes? So those are the common keywords that will refer to point to H1 not equal to. Okay, so step number 2, select the level of significance is stated, which is 0.01. Okay, so the symbol that we use to denote the level of significance, if we use alpha. Okay, so alpha is the symbol or the notation to denote the level of significance. Okay, so this is something new to you today. Okay, step number 3, what is the test stats? We are going to use Z distribution because sigma is known. Okay, so step number 4, okay, so meaning that when you use Z, the formula will be x bar minus mu divided by the standard error, sigma over n square root. Okay, so the difference between Z and T, if you recall from your previous chapter, is just the symbol here, sigma. If you're going to use T, it will be x bar minus mu divided by S over n square root. Okay, but basically it's the same thing. It's just the symbol that we change from sigma to S, because S denote sample standard deviation, sigma denote population standard deviation. So step number 3, select the test statistics. Okay, we are going to use Z lah. Okay, whereby the formula should be here. Okay, but you don't need actually to okay, in the real in your assignment later on, okay, or in the exercise from the book, no need to put this thing. Just mention step number 3, use Z distribution. That is enough. Okay, so step number 4. So this is the important part. Formulate the decision rule. When are you going to reject H0? Okay, remember the decision rule always start with reject H0. Okay, so what is your H0 just now? Our H0 is mean is equal to 200. When are you going to reject? If you can support H1, means you are going to reject H0. If the sample information that you collect cannot support H1, means you cannot reject H0. Okay, so the statement is either you reject or do not reject. Okay, you reject H0 if you support H1, okay, and vice versa. Okay, so means start by writing the word reject H0 if computed or you can use the word computed or calculated. Okay, both are the same thing. Okay, if computed or calculated Z, okay, is bigger than the critical value of Z plus. Okay, why you have two values here? Because it's a two-tail test. If you're going to use one tail, means you're going to write only one sentence. Okay, whether it's positive or negative. Okay, because you are doing a two-tail test in this example. Why two-tail test again? Because your H1 takes the form of not equal to. Therefore, when you draw your, so this is part of the solution as well. You need to draw your area under the curve. Okay, and you need to show which is the area under the curve that you are pointing at. Okay, because if you're doing a two-tail test, you need to highlight both area on the left and also on the right side. Okay, and the important part here is this critical value. Okay, so you need to, so 2.576 positive and also negative 2.576 is basically the critical value. So reject H0 if the calculated Z is bigger than the positive critical value. Okay, so in the real example, I mean in the real question, if you were to do your assignment later on, okay, do not write critical value Z plus or negative, write directly what is the value. So in this case will be 2.576. This will be negative 2.57, meaning in step number 4, okay, you need to write down, you need to mention what is the critical value. Okay, not plus or negative. Okay, so because at step number 4, you should know already. Refer to the T table or the Z table. Okay, extract or determine what is the critical value. So how do you get 2.576 in the first place? Again, this is actually the reverse process of confidence interval. If you recall just now, okay, what is our level of significance? 0.01, correct, or 1%. So if alpha is 1%, okay, so and alpha, I mean your decision rule, whether you want to reject your critical value, okay, will be based on your alpha. Okay, so remember what is the critical value? Critical value is the dividing point, whether you are going, when when are you going to reject or do not reject H0? Okay, in this problem, you have two critical value, one on the left, one on the right. Okay, one positive, one negative, because you are doing a two-tail test. So how do you determine this value to be 2.576? First, you need to know what is your alpha. Alpha is 0.01. Second, what is that? Are you going to use one tail or two tail? Because that will affect the value of critical value as well. Okay, in our case, in this example, our test will be two-tail test. So your alpha will be you need to divide by 2. Okay, because it's a two-tail test. If it is a one-tail test, meaning the sign for mu for H1 takes the form of more than or less than, no need to divide by 2. Okay, so I will show later in the other example. But because alpha is your sign, your H1 is not equal to, you are going to use a two-tail test. Two-tail test means your alpha need to be divided by 2. So what does this mean? Okay, when you draw your area under the curve, okay, you know that the area should be divided into two parts, one on the positive part and one meaning the area of rejection. Okay, whether you are going to reject is not. Okay, the evidence can take the value of positive or negative. Okay, so when I say divide the alpha by 2, meaning 0.01, divide by 2 means one area will be 0.005. So what does that mean is that, okay, this area, this one part area will be 0.005, and the other area on the right will also be 0.005, because the alpha is 0.01, you divide by 2, so the sum of the left and right area will be equal to 0.01, but one area will be half of that, 0.005. So that means the area in the middle here, the one which is not shaded, okay, the one which is not shaded here, the one in center, okay, so this area will be what? Okay, so this area actually equals to 0.99, correct? Because alpha is 0.01, so alpha is the area of rejection. Okay, alpha is the area of rejection, but because it's a two-tail test, so you need to divide the area of rejection on both sides, 0.005 on the right, 0.005 on the left. So the area in the middle, which is not highlighted here, equals to 0.99. Okay, if you go back to chapter number, the previous chapter, okay, when you construct your CI, if you want to calculate 99% CI, okay, can you remember how do you refer to the Z table? If your alpha is, let's say, if you want to construct 99% confidence interval, okay, in the previous chapter under confidence interval, if the value of your confidence interval will be 99% or 0.99. Okay, so what do you do before? You divide this by 2, right? Okay, and then when you divide by 2, okay, and then the next step will be you take the 0.99, you divide by 2, what do you get? Okay, and then okay, 0.99, okay, divide by 2 gives you 0.495. So the next step is that you refer to the Z table, the value that closest to 0.495, correct? That is how you do in the previous chapter. If you want to construct 99% confidence interval using the Z table, if 99% means you divide by 2, 0.99 by 2, divide by 2, you get 0.495. And then you refer to the Z table, find the value that is closest to the value of 0.995. Sorry, 0.495. Okay, so this is what you see here also. Okay, the one closest to 0.495 in your Z table is 2.58 here. So basically, this is just the same process. So why are you doing the same, exactly the same thing as what you did in your confidence interval topic? Because the principle to read the Z table is the same. Okay, so we know that, okay, the area under the curve, so the one that is not highlighted should be 0.99. correct? Okay, why 0.99? Because alpha is 1%. Okay, so alpha is 1%, and because it's a two-tail test, so you need to divide the alpha into two parts, one on the left, one on the right. But the main thing is that the area which is not highlighted here is equal to 0.99, correct? 0.99. Okay, so because it is 0.99, the area under the curve, because it's symmetric, you can cut the graph into half, just like in your confidence interval. Okay, so 0.99 is the area under the curve. So when you cut the graph into half, so 0.99 divided by 2, you get 0.4954 just now, which I showed just now. 0.99 divided by 2 gives you 0.495. So the area here will be 0.495. So to determine the critical value, go to the Z table, find 0.495, and you will find the value to be 2.68. Okay, that's what you see here. Sorry, 2.58. Sorry, not 2.68. Okay, 2.58. Okay, but of course the book used 2.576. You can just put 2.58. It's still correct lah. Okay, so in your, if you were to do in your exercise or your assignment, you can just put 2.58. Okay, so it's still correct. Okay, so 2.576 is more accurate lah, but 2.58 is equally correct as well. So it will be positive 2.58 and negative 2.58 on the left side. Okay, so the way to read is the same how you read the Z table when you did your confidence interval. So it depends on your level of significance. Okay, if it is 1%, then it's a two-tail test. So the main thing is that the area under the curve will be the left hand side, meaning that the one which is not highlighted here, okay, equal to 0.99. So when you split into 2, okay, you get 0.495. You refer to the Z table, you get the value to be 2.58. So then you know already what is the critical value on the right and the critical value on the left. So step number 4, reject H null if the calculated Z. Okay, okay. At this stage we have not calculated anything yet. That's why we just put here computed or calculated Z. But we know already what is the critical value. So you can reject if the calculated Z is more than 2.576, or if the calculated Z is less than negative 2.576, because whenever you do a two-tail test, your answer can be negative or positive. Okay, so that's why you need to construct two sentences here. If it is positive, when do you reject it? If the value is negative, when are you going to reject it? So basically, it's just the same value, but one is positive, one is negative. One is more than, one is less than. Okay, when it is less than, it should be negative value. Whenever it is more than, the value should be positive. You cannot have more than, but the value is negative. Then something wrong lah. Because more than always point to the right side of the table or of the distribution. Less than always point to the left side of the distribution. So less than should be negative value. More than should be positive value. Okay, of course, this thing needs practice. Okay, but if you understand the principle behind constructing your confidence interval, you should have no problem to either in the Z distribution or in the T. The T should be much more straightforward because you just refer to the T table based on the degrees of freedom. Okay, that's what you did in your T distribution before. Okay, so now in step number 4, you have constructed your decision rule. Reject H null when your Z is more than 2.58 or your Z is less than negative 2.58. Then step number 5, calculate the Z value, the Z stats, and then make your decision. Okay, so what is the formula that we are going to use? Okay, either Z or T, the formula will be more or less the same. X bar minus mu divided by standard error, sigma over n square root. Okay, so you just plug in the value that you were extracted from the question. X bar 203.5. Okay, and then so when you look at the X bar, it's bigger than the mean. So by then you know already your Z will be positive value. So you are looking somewhere on the right side of the decision already, because your X bar is 203, your mean is smaller than that. So you are going to get a positive value. Okay, so your calculated Z is 1.55. So this is what, okay, so 1.55 is actually what you mentioned here. If calculated Z is, so in step number 4, we have not calculated 1.55 yet. That's why we just mentioned in general. Reject H0 if calculated Z. Later on, if you're using T distribution, just change the word Z into T. Reject H0 if calculated T is more than what value, or calculated Z is calculated T is less than what negative value. Okay, so this calculated Z, you only can know the value in step number 5 when you plug in the value. Okay, so you get calculated Z to be 1.55. Then you need to locate the value. Meaning you need to show where is 1.55. Is it outside or inside the area of rejection? Okay, because when you, in step number 4, when you construct your decision rule, it must come together with this graph as well. Okay, so you need to shade the area on the left and on the right for a 2-tail test. If it's only a 1-tail test, meaning you're going to highlight only the area either on the right side or on the left side. Okay, but because we are doing a 2-tail test, so the area will be highlighted both left and right. But highlighting is one thing. The important part is determining what is the critical value. So we know that alpha is 1%. Because it's a 2-tail test, you need to divide by 2. So one area, so this area will be 0.005. This area will be 0.005. So that leaves the mid-center area to be 0.99. So if you cut this graph into half, because your Z table only reads the area on the right side. So this area, the one not highlighted, okay, the one in yellow here is 0.495. Report to the Z table 0.95 gives you 2.58. Okay, so that is how you get 2.576 or 2.58. Okay, so so once you have determined what is once you have performed the calculation, so 1.55 is clearly outside the area of rejection. If this value, let's say, is 2.6, for example, okay, 2.6 is bigger than 2.576, meaning it should be inside the area of rejection. Or let's say this value is negative 2.8, for example. Okay, this value must be smaller than 200, of course. But if you get Z to be less than, let's say Z is negative 2.8, meaning it is inside this area, you are going to reject as well. Okay, but here in this example, Z is 1.55, which is smaller than the area, the critical value, or in other words, it is outside the area of rejection. So this is how you come up with your simple conclusion. 1.55, okay, fall outside the area of rejection or fall within the area of do not reject. Okay, this is area of reject. The rest is area of do not reject. So H0 is not rejected. So it must come in 2 parts. First part, whether it is inside or outside. If it is outside the area of rejection, then H0 is not rejected. If this value is falls within the reject H0, okay, then H0 is rejected. So that is how you can just change the sentence. Okay, if this value fall within the reject area, so H0 is rejected. Okay, but go back to our original solution. Okay, 1.55 falls within the do not reject. Okay, so H0 is not rejected. So the conclusion is, okay, because you cannot reject. Okay, so again, what is your H1? So this last sentence here, okay, so you have 3 parts actually. Okay, so this is one part, the first part. Second part, this is the third part of the answer. The first part, whether it is inside, the calculated Z is inside or outside. Second part, whether you reject or do not reject. The third part is the meaning of your decision. Okay, even though you say that you do not reject, what does that mean? So this is the important part that you need to show that you understand what is the decision that you take from the from this practice, that from this test that you do. So to answer this, you need to check back what is your H1 and what is your H1. Okay, so because your H1 is not equal to 200, okay, so and your H0 is of course equal to 200. Okay, because you cannot reject H0. Okay, because you cannot reject H0. Okay, means that okay, so let me go back to this decision just now. Okay, what does the sentence mean? We conclude that the mean is not different from 200. Okay, so which part of this actually is we conclude that the mean or the mu lah, okay, the mu is not different from 200. The word not here. Okay, okay, so there is double negative, not different. If you say different means it's not equal to lah. Okay, the mean if different, or in other words not equal to. So you can see this as the mean is not equal to lah. Okay, the mean is not different from 200. Okay, why? Because you are referring to actually, if you reject H0 means you can say that the mean, if you reject H0 means you are supporting H1, correct? So because you cannot reject H0, so you cannot say that the mean is not equal to 200. So basically, your sentence here refers to your H1. Okay, again, because the burden of proof is in the H1. So whatever statement that you want to make for the third sentence, for the third part here, part number 3, part 1, part 2, and part 3, this part number 3 always refer to your H1. If you reject, okay, let's say we reject H0. Okay, we conclude that the mean is different. Why different? Because that is what your H1 states. Your H1 states that mean is different than 200. Okay, if you reject H0 means you are going to support H1. So your sentence will be, if you reject H0, we confirm that, or we can conclude that the mean is not equal to 200. Okay, but because we cannot reject in this exercise, okay, so we conclude that the mean is not different. Okay, it's not different, but if not equal to that, so it's not different than 200. So basically, whatever that you conclude should be referring to your H1 statement. Okay, so if you reject H0, we conclude that the mean is different than 200. Okay, but in our case here, we cannot reject, so just add the word not. It's more easier to understand. If you reject, not, don't put the word not. If you reject, if you cannot reject, put the word not lah. Okay, so that is for the Z distribution. Okay, of course, when you need practice, okay, after 3, 4, 5 exercises, then you get the idea how to construct your step number 5, your decision rule. Okay, so using the same example, but we want to know whether there has been an increase. Okay, so again, the word increase point to a value that is higher than. So increase means higher than, okay, or the value has increased. So that will point to H1 to be more than. Okay, to be more than means you are going to use one-tail test. That one-tail test will be the area on the right side of the distribution. Okay, so that is this objective here. Okay, so recall that the mean, the sample size is 50. Okay, the mu is 200. The standard deviation is 16. Okay, the rest is the same. But we change the H1 from not equal to more than. Okay, so the rest is the same. I mean, in terms of the information, okay, the main information is the same. But when you change the notation from not equal to more than, okay, everything changes. In terms of your decision rule will also change. The critical value will also change. The conclusion will also be affected as well. Okay, so if you are testing that, if you feel that the mean has increased, so this is what you want to prove. So H1 is okay, so H1 is more than 200. Okay, and then the opposite will be H0 less or equal to 200. So the main thing is construct your H1 first. If you confirm that H1 takes the sign of more than, so the opposite will be less or equal to. Okay, step number 2, alpha is still the same, 1%. Step number 3, still the same thing. Sigma is known, then we are going to use the Z distribution. Okay, but the difference will be in your critical value. Okay, just now in the previous example, you did a two-tail test because H1 is not equal to. So you have two areas of rejection, one on the right and one on the left. And your alpha was divided by 2. So the area on the right will be 0.05 and the area on the left will be 0.05. So because you divide by 2, so the remaining area here is equals to 0.99. So you split the graph into half. Okay, so this part will be 0.49. You check the Z table, you get 2.58. That's how you get 2.58 here. But now, when it is a one-tail test, okay, whether so in this case, one-tail test on the right side, okay, the value of critical value will be the same even if you are doing a one-tail on the left. But now the value should be negative lah. Okay, whether it's negative or positive. If it is a one-tail test, okay, so your alpha just now is 1%, correct? Or 0.01. So now this area is 0.01. Not 0.05. Why we get 0.05? Because we split into 2. Because it's a two-tail test. But when it is a one-tail test, the whole area in the right side, because it's a one-tail test, so the area of rejection on the right should be equal to the alpha value, which is 0.01. Okay, so that leaves the rest of the area here to be 0.99, not this part area. Okay, so how do you determine this to be 2.326? Okay, so if you go back to your previous chapter on confidence interval, okay, or even in the beginning of the Z distribution, we know that Z distribution is asymmetric, correct? So the area on the left should be the area on the right side, okay? So if this area is 0.01, okay, that's what is stated here. So, okay, let me cut this graph into half, okay? So if this area is 0.01, correct? This is 0.01. And if we cut this graph into half, what should be the remaining area here? It should be 0.49, correct? Basically, you can do the same thing as well here, okay? So because this area is 0.005, what will be the remaining area here? It will be 0.495. Okay, I mean you can use different approach. Okay, if this is easier for you to understand, you can use this one. Okay, because the graph in your Z table only reads the right side of the table. Okay, so if this area 0.01, that means if you cut the graph into half, okay, half will be 0.5, the other half will be 0.5. But because this is already 0.01, so the remaining area will be 0.49. Okay, so if you look at the two-tail test just now, both sides of the rejection will be 0.005. So if you cut the graph into half, one half is 0.5, the other half is 0.5. If this is already 0.05, so that leaves this area to be 0.495. So you go and check your Z table, the closest to 0.495. Just now, we confirm that the value is 2.58. Okay, the same goes here. Okay, because this area is 0.01, so the remaining area should be 0.49 because the total should be 0.5, correct? So refer to the Z table, 0.49. What will be the value closest to 0.49? So you will find that the value, the critical value to be 2.33. Okay, you can check back. I think if you look at this value to 0. Okay, let's find 0.49 just now, correct? 0.49, yeah, this one, 0.49. The value should be 2.33, correct? Okay, so that is how you refer. Basically, it's the same process as what you determine your value for confidence interval. Okay, I'm repeating myself many times because sometimes you cannot relate. Okay, you need to know the connection between the previous chapter and also the current chapter. Okay, so once you determine the critical value, you can see that changing the direction from two tail into one tail. Okay. First, of course, the construct of your H1 is different. So this is another, if you, in terms of marking, okay, components to mark. So correctly identifying your H1 will give you correct mark for your step number 1. Okay. So if you recall, your hypothesis testing need to follow the 5 steps procedure. So constructing your H1 correctly will be marks for your step number 1. Okay. And then because it's a one-tail test, so you need to correctly determine what is your critical value. So your critical value will be 2.33. Okay, no need to put 2.326, just put 2.33 as what you will find from the table. Okay, so that will be 2.33. So what is your decision rule? Okay, your decision rule will be this one. Okay, reject is null if this is some typo error here. You need to, this should be here. This should be, oops. Okay, reject is null if computed Z is more than critical Z. Okay, we know that. Okay, I mentioned just now, step number 4, you need to fill in what is the critical value. Okay, I do not want to see just you put critical Z. Okay, step number 4, you should know already what is your critical value. Okay, this value of course is not calculated yet. Then you can just leave it as it is. Reject is null. Okay, of course start with the sentence reject is null if calculated or computed Z is more than. Why more than? Because your H1 is more than. Your H1 is more than is a one-tail test on the right. Because it's a one-tail test, so your decision rule will only be one sentence. If you recall just now, if your test is a two-tail test, you have a two-sentence decision rule. One positive, the other one is negative. Okay, but because it's a one-tail test, then your decision rule will also be one sentence only. So reject is null if calculated Z is more than. Okay, 2.33 we take from this positive value on the right side. Remember, it should be positive. Okay, not negative because it's a one-tail test on the right side, more than. Okay, then step number 5, make decision. So in step number 4, you perform the calculation. This calculation should be in step number 5 lah. Okay, this graph should be in step number 4 because you want to show the area of rejection. So remember this graph. Okay, the area of rejection here, when you draw the area of rejection and also showing the area, the critical value should be part of step number 4. Okay, this part should be in step number 5. Okay, of course. Okay, you can move this one later lah. Okay. So again, we know the answer is the same, 1.55. Okay, so 1.55 does not fall. Okay, so the same thing here. Okay, because the critical value, although the critical value changes, but the value of Z is still smaller than 2.33, so we do not reject. Okay, we conclude that the mean average test assembled in the last 50 weeks is not more than 200. Okay, so you can write this way because basically this is what the sentence, the study is about. It's about the mean number of tests assembled. Okay. So this is more complete. Okay, but if you do not want like this, you can just even write the way like in the previous one. The mean is not different than 200 because this is just straightforward, straight from your H1. Okay, because your H1, you see that mean is more than the population mean is more than 200. So because you cannot reject, so it's not more than. Okay, it's not. So the word more because is one-tail test on the right. Okay, so but you add the word not because you cannot reject. If you reject, then you just delete the word not. Okay, why more than? Because your one is a one-tail test on the right. Your H1 is mu more than 200. So just copy back whatever that you write in your H1 in your conclusion part number 3. Remember, you have 3 parts: inside or outside area of rejection, and then what is your decision, you reject or do not reject. And then the third part, the meaning of your conclusion. So I will see that in your assignment, you need to construct these three parts solution. Okay, inside or outside, whether you reject or do not reject, and the meaning of your conclusion. If you do not reject, so okay, we conclude that the population mean is not more than 200. Okay, if you reject, okay, just remove the word not. We conclude that the mean is more than 200, meaning you are just supporting your H1. If you reject means, if you reject H0, you are supporting H1. H1 means mean is more than 200. Okay, so that is basically what you need to know. Okay, whether it's Z or T, it still be the same, meaning the process of uh, locating your critical value, okay, constructing your H1 is the same. The only difference is if you're using Z or the T distribution table. Okay, so let us do maybe now it's 11 and okay, beside being able to determine whether it is one tail test, two tail test, okay, and follow the 5 steps procedure. Okay, one more part in hypothesis testing that you need to understand is p-value. Okay, so basically p-value is you already learned in the previous 2 chapters how to calculate probability value, correct? When you determine the when you calculate x minus mu divided by standard deviation, you look at the Z table and you calculate the probability value, correct? So that was part of your test number 2, okay? And will also be part of the test number 3, okay? If you recall, chapter number 6 is using sampling distribution, okay? You need to divide by the sample size. But if you want to calculate the area under the curve, okay, meaning what is the probability value of x more than, x less than, or x between the two values, okay, you can refer to the Z table and determine what is the probability value. So that is what you have learned before. So that skill is basically what you learned in the previous 2 chapters, okay, calculating the probability value using the Z table is the same skill that you need to use, how to determine p-value. Okay, so first, what is p-value? P-value is the probability of observing a sample value as extreme as or more extreme, blah, blah, blah. Okay, I'm sure you don't understand this statement. Okay, just now we mentioned that if you want to reject or do not reject H0, one way to do it, or the main way that we teach you in this syllabus is based on the calculated Z, and you compare against the critical value. If you get the calculated Z, let's say in this example just now, 1.55, okay, 1.55, and then you compare against the critical value, which is 2.33 just now, okay, and because it is less than, then you cannot reject. Okay, so this is what you have covered just now. Okay, so you calculate the Z value, you compare against the critical value. If the calculated value is more than or inside the area of rejection, then you're going to reject. If the value is less than the area of rejection or the critical value, then you are not going to reject H0. That is one method. The second method is to use p-value. Okay, so what is p-value? Okay, so just now, okay, if you look at this simple example here, okay, so the way you determine the p-value is basically using the calculated Z that you have determined just now. Okay, so if you, okay, just now, if you look at the value of calculated Z, you get 1.55, correct? So if you look at 1.55, okay, in the Z table, okay, in the Z table, what is the value corresponds to, okay, if you look at your Z table, okay, let me go down here, okay, here under, okay, remember, okay, the value of Z is 1.55 as what the question mentions just now. So 1.55 means what? 1.55 is this one, right? 1.55. Okay. Okay, so 1.55, the area under the curve is 0.4394. Okay, 0.4394. Okay, so remember, okay, so the value of 1.55 is 0.4394. Okay, so let us go back to this. Okay, example again. Okay, so we know that 1.55 just now correspond to 0.4394. So what does this mean? Okay, in the previous chapter, when you learn how to locate the area under the curve, okay, if your z value is 1.55, okay, 1.55 means that the area under the curve. Okay, so what is the area under the curve? Means this is the area. Okay, the area from 0 to 1.55 just now equals to 0.4394. Okay, so that is the area from this part to this part, 0.4394. So what is p value? P value is the area to the right of the value that you calculate just now. Means that 0.4395 in this area. So P value is the remaining area here on the right side of the tail. So that is what the extreme value. Okay, so basically to get P value, you just use the formula 0.5 minus by the value that you read from the Z table just now, which is 0.4394. See, 0.4394. So if I use my calculator here, okay, minus 0.5, okay, I'm going to get 0.06. Okay, so this is what, 0.06, correct? So this is what your book shows. Okay, so 0.06, you get it by using 1.55, refer to the Z table, you will get the area under the curve from this part to this part. So P value is basically the remaining area on the right side of the tail. So you get 0.5 minus 0.4395 just now, you get 0.0606. Okay, so the P value can also change, okay, depending whether you are using one tail or two tail. Okay, if in this example just now, okay, you recall that, okay, in the earlier part, we did a two-tail test, correct? Because the sign, the H1 is not equal to. If you're using a two-tail test, your P value also need to be divided by 2. Okay, if you recall just now, okay, your calculated Z is 1.55. So when you refer to the Z table, we get our P value 0.0606, correct? So that is what we get when you refer to the Z table, 1.55. That value you minus by 0.5, we get 0.0606. Okay. However, this P value, you can only use, you can say that the P value is equal to this if it is a one-tail test. But if it is a two-tail test like this one, you need to divide this value by 2 because you need to refer to the area on the left and also area on the right. So 0.06 divide by 2, you get somewhere around 0.0303. So the P value actually equals to 0.0303 if it is a two-tail test. But if you're using a one-tail test, then directly use the value that you get from the calculator. Means look at the Z value, the value that you read from the table, minus by 0.5, you get 0.0606. If it is a two-tail test, you need to split into half because the area is shared on the left and the right. But if it is a one-tail test, this actually will be the P value. So what is the purpose of the P value? So P value basically is, you use P value also to make your decision whether you are going to reject or do not reject. Okay, but at this stage of your syllabus, we're not going to focus on using the P value to make your decision. Decision means, are you going to reject or do not reject? Rejection is based just on comparing the critical value and the calculated Z. Okay, but you are going to use the P value not at this subject, but in your basic econometric subject. So in that subject, you will learn to use p-value. So at this stage of your syllabus, you just need to know how to determine the p-value. So the p-value, whether you are using the Z table or in the T table. The T table is slightly different. Okay, I'm going to show you later on. Okay, but for Z table, for Z distribution, it is very simple and straightforward. The value of the Z that you get here, 1.55. Check your Z table. Okay, what is the corresponding value of area under the curve? Okay, that corresponds to 1.55. We know that it should be 0.4394. This value minus by 0.5 minus by 0.4394, you get the value to be 0.0606 just now. So that is the p-value. But if it is a two-tail test, you need to divide it by 2. So that is the p-value for a two-tail test. But if it is a one-tail test, either on the right or on the left, the p-value is 0.0606. Okay, for that example, when the Z is equal to 1.55. Okay, so today again, no exercise. Okay, we will discuss more. I will give you some exercise on next Monday. Okay, because most of the questions that I prefer to give will be on the T distribution. Okay, because that is more relevant to the actual research process. Okay, so I think that's it for today.